Hey there, ClassPad.net users. So today I'm kind of continuing what you can do with images. So I made a video before on how to upload images into ClassPad.net, and so now I'm going to show you how to do some curve fitting. So I'm working with linear just because it's quicker and easier, but what I'm doing here you would do with any other type of curve. So you can do it by plotting points and using your equation, slope, intercepts, those types of things to have students find an equation to fit based on your points. Or you can also include an actual regression, which would mean statistical measures. So we're going to do both just to show you. So here's an image. I've got a bridge. It's got lots of lines. I'm going to be looking for the equation of this particular line right here. I could pick anyone. I'm just choosing that one. So when you are in your graph, you've got your choices for equation, some statistical plotting on top of that if you want to do it. We already have our picture uploaded. That's what this represents. It's centered. Here's the size. And then this is our plotting point. So I'm going to plot points. I'm going to change the color of this so that it shows up a little bit better on my graph. So the points I plot, it doesn't matter where I plot them. I just want to make sure they're showing up on my graph somewhere because I'm going to change them. So let's just make some easy points that I know are going to show up on my graph. So as you see, as I'm plotting them, you should see them showing up over here in the graph. So there's the 4 points. I'm just going to plot 4 because I really only need 2, but we'll plot 4. So you'd plot the points, and then here's the cool thing is once you plot them, you can notice when I click on them, the coordinate comes up, and now I can move them to fit on my line, right? So I want to match up my line. So let's try to make some nice ones. That looks pretty nice. And that's okay. So I've got some good. Let's get some in this quadrant over here. And again, your students would be doing this, so they would probably be coming up with completely different points, which is great because you want them all working on something different so that they can see, depending which points you choose, you get a different equation, but they're all equivalent to that line. So I have 4 points. I want to now have my students fit a curve, make an equation, so they're going to be using what they know. So they could try to find the intercepts, the y-intercept, and use that, find the slope. But I like the point slope form because I've got points, right? I've got points. I can use 2 points to make my slope, and then I don't need to really kind of focus in on that intercept at this point. So let's pick 2 points, and depending what you do, I'm going to pick ones that look kind of nice. So I like this one, and I like this one. So I'm going to just hide the other ones just so they're not in my way. So I've got these 2 points, so I need to find the slope from those 2 points, and I need to create that point slope equation. So now I'm going to go down here to my graph and get my equation. I'm going to change the color of my graph to match so that when I graph it, it's on top of my lines. So point slope is y minus the y coordinate of a point equals the slope times x minus the x coordinate of a point. But since we are in our equation, we can only do y equals, so keep in mind that that y minus problem's going to number, x, y coordinate is going to be moved to the other side. So let's find our slope first, and I can use my points. And this is the cool thing, this is a calculator, you can just do everything up there. So it's the difference in the y's over the difference in the x's, change in y over change in x. So let's just do it as we see the points. So let's do the difference of the y's. So 4 minus 3 is my difference in the y's, and negative 2 minus 0.5 is my difference in x's. And now I'm going to multiply by the x. Now I need to pick one of the points. It does not matter which point. In fact, I could use one of the points that's not even in my slope. I could use one of these points if I want, or I'm sorry, one of the ones I didn't select. I could use this point if I want. But I'm going to focus on, let's just use one of the easier ones. I like this one because it's easy. So so let's do x minus a negative 2 makes this x plus 2. Whoops. And then remember, it's y minus this y coordinate, but because I've moved it to the other side, it's really now plus 4. Okay, so I've used this first point as the point in my point slope form, and I found the equation by finding those, I found the slope by using these 2 points. So now I'm ready to hit enter and see if my equation matches. And there it is. It's going through my points, which is what I expect. So I have this nice equation of my line that I really had to work for, right? As a student, I had to find the slope. I had to know my equations, do some operations, those types of things. So that's one way to be working with curves and finding a line of fit. But let's go down to another way, which also involves points, but it also involves the computer basically checking your equation in the end. So here, instead of doing plot points, which literally just plots points, I'm going to do statistical points. So this time I'm going to use the same points to start, but notice that this time the points do not automatically go on the graph because I'm in statistics. I'm using a spreadsheet. So in order to get the points onto the graph, I need to actually create a statistical plot, which in this case I selected my X column, my Y column, and I'm going to do a scatter plot. So now there's those points. So it's an extra step doing the statistical, but in the end it gives me a check of my equation. So here's the points, and just now that they're on the graph, I can click on them just like we did before and move them so that they have a nice, so notice I'm kind of doing the same points here just to kind of show a point. So let's pick the same two that we did in the one up above, right? So the only difference at this point is I use statistics, so I had to do an extra step of making a scatter plot. But I can do the same thing. I can have my students do the exact same thing, write that equation that they think fits. And since we already did it up above, let's just go up above and cheat a little bit and copy, whoops. And, all right, I don't know why it's not letting me. There we go. And copy it and bring it down here so I don't have to do it. So basically, I've done the same thing I did before, except I forgot my y equals. So this should, we know, go through the line. So there, we did pretty good. But now, because I did this with statistical plot, I can actually now check my equation, see how good it is, or maybe come up with a different equation by doing a regression, which you can only do if you have the statistical plot. Or the statistical points in the spreadsheet. So now I'm going to add a check, and this is linear, so I want to do a linear regression. And notice, this is my linear regression. It's kind of a check, and here it's giving me an equation in the slope-intercept form, which is not the point-slope form. So I could now have my students click on here, make another graph, and let's make it be yellow to match what's down here, and use the regression to create a second line. So they're saying me that it's negative 0.4. Let's make sure we're just seeing this right. 4,1, let's just do 4,1 times x plus 3.16, right? So this is the regression equation. And if I'm right, it's right on top. It's a little, if you notice, it's a little off. So now we can have students compare these two different forms of the equation. Are they equivalent? What's different? That type of thing. So this is a great exercise. So depending on what you want, if you just want them coming up with an equation, that's fine. But if you want them to have equations in different forms and have a check from the calculator to see how good their fit is to the actual line, you can do the statistical plots. So two different ways to do this. Have fun exploring, and follow us on Twitter, Facebook, and YouTube. Thanks.